called radicals. And when we work with radicals, we're going to have rational exponents. Rational exponents are fractional exponents. So all these properties still hold true with fractions. You're just going to be adding, subtracting, dividing, multiplying fractions. So all these properties don't change. Just want to give you a couple minutes here. Bless you. Try those few out, and then we'll check and see. Also, I know that a lot of the calculators are getting to the point where the batteries are starting to die out on them. If your battery looks like it's ready to croak, I have a couple of the cords that you can borrow if you'd like, where you can just take home and plug it in your phone charger overnight, and then it'll be fine. If you don't want to leave it in the room for during the day while you're using it, or if you've got it in the classroom to go to. I have plenty of those cords if you guys want to take one, by all means. Just make sure you don't lose it. You need one?
No, this is like, if I'm in a classroom and I plug my calculator into the wall, do you think I'll get in trouble?
I hope not.
Because I know they'll yell at you if you plug your phone in.
True.
What, they do?
Yeah, they do.
Some
You're not
people
allowed to do that.
You're stealing the electricity from the taxpayers.
It's actually because if there's a short and like it breaks your phone, then like the school is liable because.
That's more.
My flex teacher said.
Because he made it so that it just typed a ton of ones and zeros, like no matter
Oh
what
yeah,
I
and
tried
then
to
it
do.
gives you overflow error. And
All right, guys, let's take a look
So
here.
mad.
So first one, you have a whole bunch of stuff raised to the negative third. So right off the bat, you know that everything in there is unhappy. So it's 1 over all of it. So you get 1 over 4 cubed, x to the 9th, y to the 15th. Now, if this is the calculator portion of the test, I'm assuming you can press the button that's 4 cubed. Or you could probably figure out 4 times 4 times 4 is 64.
Yeah.
Okay. When you do the next one, you cannot multiply the things together yet until you distribute these the squared in the second parenthesis. So you have to rewrite this one out. You're going to get x to the 4th, y negative 3, x to the 6th, y to the negative 4. Which means the y's aren't happy. So you send those down, and you combine everything. You wind up with x to the 10th, y to the 7th. In the fraction one, you do the same basic principles. You have to distribute out that negative 2 power to each piece, which in essence flips everything. So you wind up with y to the 6th over 4x to the 4th. Now if you write it out by step, you can just distribute each part first and then flip it if you'd like. Okay. Not a big deal. And then lastly, you just rewrite everything so they're happy. Then we have x to the 9th. Play the game of war of the 6 and the 4. Who wins? What's 6 minus 4? 2. And there you go. It's a lot of stuff to remember, yes, but as we went through the rest of the unit, we dealt with exponents pretty often, and multiply it, add them, both like that. After we did that one, we started to do our end behavior, our tails, and I think by now we all understand tails up, tails down, dance moves and all that kind of junk. We wrote it out a lot of times in terms of a positive, even, negative, even, positive odd, and negative odd were the only 4 scenarios you had. Yeah, it was something in there. If it was positive, even, what were they doing? In a way. Negative, even.
Up, down. Down,
Down,
down.
Positive, odd.
Down, down. I'm kidding, of course.
He deflect. And then negative odd.
Up, down,
Oh my gosh.
up, down.
Please stay in school.
Mr. Murphy, you put out your people.
Please just be like, you take the first point away.
That's what.
Fading. It's a fading glimpse. What was 6-3? Oh yeah, 6-3, adding, subtracting, and multiplying. All you have to be careful with here with the adding and subtracting is that you combine like terms. That's all that was. And distributing the negative, right. Okay. As far as that, there wasn't really any real trickery to any of that. Some of the trickery wound up when you had this. Because what do you have to do?
Multiply by 2x plus 3 by 2x plus 3.
By 2x plus 3. We were getting there. Yeah. You just have to write it out 3 times, okay? This is where most people also killed like 3 puppies as opposed to just 1. So make sure that you have to write it out 3 times so you don't do that silly mistake. And then just watch when you combine out your like terms, you can easily make a silly mistake in combining, okay? That just means you multiply it out that many times. Yeah.
When you're doing that, do you multiply out the first two and then you take
It doesn't matter. It doesn't matter when you go
But
to
you
first.
can't go like, you can't do 2x times 2x times 2x.
It would just be 4.
You foil, yeah, that's what you're saying. You foil
do
2 of them,
at a
yeah.
time.
Foil.
Okay. After this one, we started to do that good old-fashioned long division. And I know you guys loved long division. It was one of your favorite things in the whole wide world.
Hell yeah.
So if I want to use long division on a problem like this,
Oh, I forgot all that one.
What is this?
Oh, bad.
This is the whole division.
4, 5, somewhere in there. After a while, all these sections kind of blended together. Once we started doing synthetic division, it kind of was the same thing over, whether or not you're looking for real zeros or all zeros. So if you wanted to use long division, remember, you always had to have a placeholder in case you need it. So you look at, we have an x cubed, which means I should have 4 terms in descending order, which means they have to go in descending order. This one is, and I have all 4 terms. So I put the x plus 8 on the out. X cubed,
Oh, I remember
16x
this.
squared, 58x, and minus 41. And now you start trying to eliminate first terms. So what you ask yourself is, how do you turn an x into an x cubed?
Square.
By multiply by x squared. Now, which one of these do you think you should put the x squared above?
16x squared.
Put it above the x squared, right. Put it above that one. And now you're going to multiply this value to both of these here, and you get x cubed plus 8x squared. Here's where most of you guys were making your mistake. When you get to this point, remember, you have to subtract. You're not just subtracting the x cubed, but you have to subtract this one as well. Make sure you put this extra subtraction between them so you don't forget that. Because a lot of times you guys will write 24x squared. But 16 minus 8 is 8. And then just drop the next one down. So then how do you turn an x into, very good. So now you're eliminating the x with the 8x squared. So you have to do a positive 8x. Send it back in. And again, subtract, subtract. And you get 58 minus 64, and I believe that's negative 6. No. Negative 6.
Well, man, celebrate.
Wave your hands like you just don't care. Because it's
I-
up, up.
I really don't care.
Durka, Durka.
That was terrible.
You don't remember that?
No.
You've never seen that?
Team America?
I
World
said it.
Police.
I almost said it
World
too.
Police.
Yes, I almost
Oh
said
yeah,
it.
it's
Wait,
such a
Team
bad
America.
movie.
It is.
The one with the puppets?
I was like, was
Yeah.
that racist?
I
Oh,
own
it
that
was
movie.
super racist.
No,
Super
no, it's the international call for help. Durka, Durka. And that's what
I
we do
own
this.
that movie. I didn't know what it was, and then my brother sat down and watched it, and then made the rest of the family watch it with him.
So then you have the,
Why did you just reference
so you wind up with a positive 7 as your remainder. And what do you put the 7 over?
X plus 8. 7.
And 9.
No, I was just saying that I forgot about that.
7.
Yep, can't write R7.
I was gonna put 1 over 7, so then I was like, that's not right.
If you were dividing by 8, yeah. No, if you're divided by 7. And the remainder is 1. Neither of those are happening. Good conversation, JC. Then after that, we just kind of stumbled into working with synthetic division over and over and over again. And when you're working with synthetic division, it's a matter of how do you know what to start with? Well, you had to use what was called that rational root theorem. The rational root theorem was the one where you list all your factors of the tail, divided by all the factors of the leading term, plus minus. I know on some of there's a couple of homework problems I'm going to have you guys here, this review pack that I made, is that the rational root theorem doesn't work because it's going to come up with irrational roots. They're not imaginary, there's going to be like, x squared minus 4, or x squared minus 7, something like that. It doesn't work as much. Yeah. So there's a couple of tricks when it comes back into factoring, and I want to show you a couple on this real fast. What I did here is I'm sitting in the wrong spot. What I have here is just some review stuff. We're going to go over pretty much the bulk of this tomorrow then. What I did is I've already posted the answers on the website. So the answers are already posted with the worksheet itself on the website, so if you need to double check if you got it right or wrong, by all means look it up. Oh, I hate staples. It always gets stuck as I'm trying to count. That's why I gave up counting. I did pretty good so far. Then I don't have that many handouts.
Yeah, Miss A, she,
50, and we have like this section.
you can't even.
So, yes, sir. It's review stuff. I don't collect reviews, I just kind of get reviews. There's lots of it. So what I want to do here is look at, what was the number here?
No, you're fine.
Where was it? Take a look at number 14. And it goes back to the factor stuff. You're going to ask?
It's kind of like off topic, but how do you make like a line that's straight up and down in the calculator? Because I can't figure it out.
You can't because it's, you have to have x equals a number and you have a y equals number.
Okay.
So you make y equals 2 and turn it sideways. Shut up. So if I want to factor this completely,
Give him +1. Give yourself +1.
I don't need it. What's the first rule of factoring? 14. What's my GCF? 3. So if I'm factoring this, I'm just going to leave the 3 here. I'm not solving for zeros. I'm not doing anything like that. So the 3's got to go along for the ride. So now there's 3 terms, and your degrees are going down by, it goes 4, 2, then nothing. This is when you treat it like a regular trinomial. Yeah. Because what times what 6 you add together to get 5? So you wind up with x squared plus 2, x squared plus 3. Can I factor that any further? No. And I'm done. No.
Is that X?
It'd be negative.
Okay, same thing.
It'd be imaginary. Yes, sir.
If we do that, because it's actually plus 15x, if we did that with the x's instead of the u's, would you take the x out?
Okay, fail. Yeah, no, it's no big deal. I always seem to revert back to x's and y's. It's just one of those things. One of the other things that has shown on here, still trying to remember what it was. Scary. Take a look over at number 21.
What's 9 plus 10?
6. I'm going to write a polynomial that has those as roots. Well, I'm given these two roots. What would have to be the degree of my polynomial? 4. Very good. It's got to be 4. It's got to be a 4th degree polynomial because if I'm given one of the I values, I must have the other I value. Okay. So we start by writing that out. We have 3 plus 3i. I have to have a 3 minus 3i. Negative 2 plus I, and then I should have a negative 2 minus I. Now, when we multiplied these things out, we treated it just like we did a regular 0. We would take x minus our 0 each time, and then we would distribute the negative and rewrite. So we would get x minus 3 plus 3i, x minus 3 minus the 3i, x minus negative 2 plus I, and x minus the negative 2 minus I. Some of you guys might have already realized that there are some shortcuts to this, which is fine. I'm still going to go ahead and put them through. Distribute out your negative, you get x minus 3 minus the 3i, x minus the 3 plus the 3i. In the brackets today. X plus 2 minus I. X plus 2 plus I. All I did there was distribute out my negative each time. And now I set myself up for difference of squares for both of them. I'll have to take the x minus 3 quantity squared minus the quantity 3i squared. X plus 2 quantity squared minus the quantity I squared. That was the trick to doing these. And the other one was on the other one, I put the squared symbol on the inside of the parentheses because it doesn't change anything. No, it doesn't, Murphy, because there's no coefficient. But the coefficient's 1.
Mr. Murphy's talking to himself. Guys, I think we need to call for that.
My mom works as an affiliate of DCFS. She knows some great people.
Cool.
They'll take care of you there.
So you get x squared minus 6x plus 9. What is the quantity 3i squared equal to?
9.
Is it positive 9 or negative 9? Negative 9. And then here I have x squared plus 4x plus 4 minus negative 1. So what's 9 minus negative 9?
18.
And then you would just multiply all of that out, get your fourth degree polynomial. Writing a polynomial of least degree. I think that was 6, 7,
6, 7, yeah.
6, 7, yeah. Other than that, I mean, man, we flew through a lot of finding the real zeros and stuff, finding all zeros, finding real zeros. That's just a matter of looking at the terms, work with the rational root theorem, use your synthetic division. Remember, anytime you get to a third degree polynomial, what should you always do? Check for? Yeah, your group. Try and group every time you get to a third degree polynomial. I mean, other than that, I'll have a couple more of those things for us tomorrow to look at. But yeah, this is a good starting point. Go try and get through as much as this as you can. Check some of your answers. Like I said, I put them online. You can pop through them and see what's there. And if there's something that doesn't work out right, we'll work on it tomorrow.
Hey, can I get a post pass?
Set 'em up.
There's one more in the year. We had yesterday.
Yay!
12.
Really tiny.